We are talking about angles of elevation and angles of depression, and we want to solve problems using angles of elevation and angles of depression. And we want to use angles of elevation and depression to find distances between objects. So here we have some example problems. And number 1 says, a monkey hanging in a tree, 68 feet tall, spots a banana at a 23-degree angle of depression. What is the direct distance from the monkey to the banana? So we got to add some drawings or some lines to our drawing here to kind of turn this real life situation into a right triangle. So the first thing we want to have the ground, and that looks like that's going to be the ground right there. And then we know that the monkey's line of sight is 68 feet in the air. So wherever the monkey's line of sight is, right there is his eyeball. You want to draw a line straight up and down from there. And we said that that was 68 feet. Now, for an angle depression, we need to have a line of sight. So from the monkey right there, from his line of sight, we want to go straight across. Make a horizontal line. So the thing that we know about this line, this horizontal line, is parallel to the ground. And now it says it has, so that's 68 feet tall, and there's a banana at a 23-degree angle of depression. So if we go ahead and make that angle of depression right to there, this is the monkey's line of sight to the banana. And the angle of depression is 23 degrees from the horizontal line to the line of sight. So that's 23 degrees. So because these two lines are parallel and they're cut by transversal, we also know that this angle right here is also 23 degrees. So what does the question ask? The question asks, what is the direct distance from the monkey to the banana? So we could get to the banana by going down the tree and walking across the ground, but that's not what it's asking. It's asking for the direct distance. And because we made this a 90-degree angle right here, we know that of this triangle, our hypotenuse is always across from the 90-degree angle. So this is our hypotenuse. So it's actually asking us to find the hypotenuse. Although this angle could help us, we could put some more numbers over here and figure it out. We know two of this triangle. We know the angle and we know this side, and we can use that to calculate our hypotenuse. So we have to label the other sides. We have adjacent and we have opposite. So which ones help us out? Adjacent, we don't have any measurements for, so we want to use O and H, and O and H are going to be SOA. So we can write out our equation. Remember, SOA means sine of theta. Sine of theta is equal to, and in this case we're talking about opposite over hypotenuse. And we can substitute in the values that we know. So we know sine in the angle that we were given is 23, and that's going to be equal to opposite, which is 68 feet. And we don't know the hypotenuse. So we want to solve to figure out what the hypotenuse is. So we're going to multiply both sides by h. So our h and h cancel on the right side. And on the left side, we're going to be left with h times the sine of 23 degrees is equal to 68. Now we want to get h by itself. So what we're going to do is we're going to divide everything by the sine of 23 and divide by the sine of 23 degrees. And I'm just going to rewrite what's left because our sine and sine cancel. And so we're left with h is equal to 68 divided by the sine of 23 degrees. So we can use our calculator and we can plug those values in, and we get 68 divided by the sine of 23 degrees, and we get h is approximately equal to 174 feet. So basically, once we were at this step right here, we moved up here and continued our equation. Next one we have is example 2. And it says, a forest ranger is in a 90-foot observation tower, sees a fire. The angle of depression to the fire is 7 degrees. What is the horizontal distance between the tower and the fire? So again, we got to add 2 horizontal lines. We got to add the ground, and then we got to add the horizontal line from there so we get our angle of depression. So we have that line to the ground of the ground, and then we have our horizontal line that comes out and is exactly parallel. Now you can kind of see that there's maybe a person standing there, a little dot. So that's going to be the person that is 90 feet in the air. And the reason that we draw this line is because we show that this line and the ground are parallel. So then we're told that the tower is 90 feet in the air. So right here to the line of sight right there, down to the ground, and that is going to be 90 feet. And this makes a 90-degree angle right here, straight vertical up from the ground. And then it tells us that we have an angle of depression of 7 degrees. So from the ranger's line of sight to the fire, and because this is a 90-degree angle right here, we know that the side opposite is our hypotenuse. So we're told that the angle of depression is 7 degrees. And then because we have parallel lines, we have alternate interior angles. So the angle of elevation is also 7 degrees. So what is the horizontal distance between the tower and the fire? So what is the horizontal distance from the tower to the fire? We want to know this distance right here. And if that's the hypotenuse and the angle's here, that means that the distance along the ground is adjacent. And that means that 90 feet is opposite. So now we can decide what are we going to use here. And we can use tangent, cosine, or sine. And in this case, hypotenuse doesn't really help us out. So sine and cosine are out, so we're going to use TOA. And TOA is the tangent of theta is equal to the ratio of opposite over adjacent. We're going to substitute our values in. We know the degree is 7 degrees, so we're going to say tangent of 7 degrees is equal to, we know our opposite is 90, and we want to calculate our adjacent. So we have our variable in the denominator, which we don't like, so we're going to multiply both sides by adjacent. So adjacent cancels adjacent, and we're left with adjacent multiplied by the tangent of 7 degrees is equal to 90. Now we want to solve to get a by itself, and there's multiplication here. So we want to divide both sides by the tangent of 7 degrees. So the tangent cancels the tangent. And I'm going to rewrite what's left up here. I'll take this up here and we'll continue. So the tangent cancels the tangent, and we're just left with a is equal to 90 divided by the tangent of 7. And when we type that in our calculator, we get a is approximately equal to 733 feet. Another example, number 3. A 20-foot ladder leans against the wall so that the base of the ladder is 8 feet from the building. What angle does the ladder make with the ground? Okay. So there's a few pieces of information we have. It says that it's a 20-foot ladder. So this is going to be 20 feet right here. And it says that it's placed against the wall so that the base of the ladder is 8 feet away. So here's the wall, here's the ladder. And we have our ground. And the distance from the ladder to the ground, to the wall, so from the ladder to the wall, that is 8 feet. So we have 8 and 20 are given. Now we know that most walls are built so that they're perpendicular with the ground, or that means that they are 90 degrees. So this corner of the wall, put the box there to show that the wall and the ground make a 90-degree angle. So we can identify, because we have our 90-degree angle right here, we can identify that the ladder represents our hypotenuse, or the hypotenuse is 20 feet. The question is asking us to find the angle of the ladder. So that angle we're going to represent with theta, because we don't know what it is, but that's what the question is asking. So if this is theta, then the brick wall would represent opposite, and the side that makes up the angle is going to represent adjacent. So we have adjacent and hypotenuse. So that means that we are going to use ka. So we can set up our equation, and our equation is going to be cosine of theta is equal to adjacent over hypotenuse. And then we can substitute in the values that we know. In this case, we don't know the angle, so we're going to keep that as the cosine of theta. And because of the way we have to solve this, I'm going to move this over a little bit and put some space. So the a value is 8, and the h value is 20. Now, we want to get theta by itself. So we need to do our inverse operation. And our inverse operation of the cosine is inverse cosine. So inverse cosine of both sides of the equation. So our cosine cancels our cosine, and on the left side, we are left with just theta. And on the right side, we're left with the cosine inverse of 8 divided by 20. Divided by 20. So we can substitute that into our calculator. And when we do that, we get a value of theta is approximately equal to 66.4 degrees. We will get number 4. A surveyor is 130 feet from a tower, and the tower is 86 feet high. The surveyor's instrument is 4.7 feet above the ground. Find the angle of elevation. So there's a few extra lines we have to draw on this one. So we still have the ground, which is going to be right here. But now we have an added piece of information that says that the surveyor's instrument is 4.5 feet off the ground. So here's the surveyor's instrument, and there's a horizontal line from the instrument that is 4.75 feet off the ground. So from there to there is 4.75 feet. Now a surveyor is 130 feet from the tower. So that means that the distance from the surveyor to the tower is 130 feet. And the tower is 86 feet high. So now the tower is not getting measured from here, the tower is getting measured from the ground. So the tower goes up to here and goes all the way to the ground. So this is 86 feet. And find the angle of elevation. So we want to find the angle of elevation. So in this case, I'm going to find the angle of elevation from here to here. And we don't know what it is but we know that we are looking for theta right there. So now we have to decide what pieces of information we have and what else do we need. So the tower hopefully is built straight up and down. So this is a 90-degree angle with this horizontal line and the tower. So we know that that's a 90-degree angle, so we make that triangle. And then we have the hypotenuse is right there. Now we don't actually care about the hypotenuse in this situation because we're given measurements for the opposite side and we're given measurements for the adjacent side. So this is adjacent because the angle's right here, so 130 is adjacent. And although 186 is helpful, it's not completely helpful because that's not the side of the triangle. The side of the triangle stops right there, and 86 goes a little bit further. So we need to find out the distance from this blue line here up to the top of the tower. So we need to do a quick subtraction. So we're going to say 86 feet is the total height of the tower, but the instrument is set up 4.75 feet off the ground. So we're going to subtract 4.75 feet. And we get a new dimension that is 81.25 feet. So that is from the instrument up to the tower. So that is going to be our opposite, is equal to 81.25. So the two sides that we are given, we're given opposite and adjacent. So we're going to use TOA. So TOA stands for tangent of theta is equal to TOA is opposite over adjacent. And we can substitute our values in. We don't know what theta is, so we're going to leave it as the tangent of theta. And that is equal to, opposite in this case is 81.25. And adjacent is 130. Should have left a little bit of space, but that's all right. In order to get tangent away from theta, we have to use our inverse function. So in this case, we're going to say the inverse, tangent inverse of the left side, and we're going to do the tangent inverse of the right side. So the tangents cancel the tangent, and we're going to be left with, on the left side, we have theta, and on the right side, we have the tangent inverse of 81.25 over 130. So then we get theta is approximately equal to 32 degrees. We have one more example problem that we can work with. We have number 5. The two are standing 173 feet away from the base of the Eiffel Tower. From the eye level, 5 feet above the ground, you notice that the angle of elevation to the top of the tower is 80 degrees. What is the height of the Eiffel Tower? So in this one, kind of similar to the last one, with we're standing above the ground a little bit. So first thing we have to do is we have to draw the ground. Then we have to put a tourist, and the tourist can stand over here. And the eye level of the tourist is 5 feet above the ground. So that looks about right. So here's the eye level of the tourist right there, if he was just going to look at the Eiffel Tower. And that is 5 feet. Then, when the tourist looks up at the top of the Eiffel Tower, he noticed that the angle of elevation is 80 degrees. The tourist stands 173 feet away. So, because the angle, you know that this is going to be adjacent, and that's equal to 173 feet. Now it says, what is the height of the Eiffel Tower? So we can't calculate the full height of the Eiffel Tower because we're going to have to add 5 feet on afterwards. But what we can do is we can continue to draw our triangle. So our triangle, our 90-degree triangle, is going to go from the top of the tower straight down to the eye level of the tourist. And that is going to form a 90-degree angle right there. So because that's a 90-degree angle, we know that across is the hypotenuse. Now the hypotenuse doesn't really help us in this case because we want to know the height of the tower. We are given adjacent, and now we need to calculate opposite. But we have to do opposite plus 5 because this is 5 feet right here from the bottom of our triangle down to the ground. So we have to calculate opposite plus 5. So the first thing we have to do is calculate opposite. And we have opposite and adjacent, so that is going to be TOA. So TOA is tangent of theta is equal to opposite over adjacent. So we go through and we can substitute our values in. We know that the tangent of 80 is equal to opposite. We don't know what it is right now. And adjacent is 173. So we want to solve to find out what opposite is. So we multiply both sides by 173 and multiply both sides by 173. So this 173's cancel, and we're left with 173 times the tangent of 80 is equal to opposite. So we can go ahead and calculate that. And when we do 173 times the tangent of 80, and that is equal to about 981. Go ahead and say 981.13. So 981.13. And that is an approximate. And then it says, what is the height of the Eiffel Tower? So over here, we had to do plus 5. So the height of the Eiffel Tower is going to be 981.3 plus plus 5. So the height of the Eiffel Tower is going to be approximately 986.13 feet.